any additional information it'll help everybody. So what we're doing now, for those of you kind of joining in as we come in, this is this is in the archive folder of the OneDrive shared folder, and it's the original. Sorry, I'll go right back to that. It's the original dosage calc study guide, and then I've just kind of edited it a little bit over the years. And then Karen had asked me about the some of the answers, and because I didn't have an updated key for anything that I had changed, and so we're just going through and double checking some of the work.
I didn't
Anything
get
that's
14. I didn't get 14 right, unless
okay.
it's a different problem. I don't know, because that's like totally different than what I got.
Okay, so let me just
14 was like a two-step problem. It was the bolus and the infusion.
okay.
And
So
I
let me
didn't,
just
yeah.
write that down.
And actually the like you had some answers on the other one that we went over, and I got it right on this one. So
Okay,
I don't know if they're all the same.
and
But
there's a
I can look at that
possibility.
test, like the one that you just sent with that answer key and practice those too. So
Okay,
yeah. But that was I'm way off on that one for number
okay.
15.
And like I said, there might be a difference in the actual numbers, so that
Yeah.
might be why that is. So we're gonna figure that out.
15's wrong. Like I said, it's probably not the same problem, maybe. I don't know.
Right.
I think
That's
it's
what
16.
16.
I
Yeah.
think 17's wrong. 18's wrong.
Okay.
Sorry, there's 19's right.
Woo.
Okay. 20's good. 21. I didn't get 22. Okay, wait, hold on a second. 22 is like a two-part question. I got the second answer right.
Okay. We'll look at that one too.
23, totally different answer. So like I said, it's probably different problems. 24, didn't get that. And 25 and 26 aren't, I didn't do 25 and 26 yet. But then I stopped because I just didn't understand the nitroglycerin drip. So
Okay. So let's start there. Let's start with the 14 through 17, and then we'll kind of work through it. And I'll just do the updated the one that I've that's the most updated. So yeah, so this is number 14. This is the one that I worked through earlier today. So the let me just see what the answer key was for that. And I realize I'm still in the key, so 4 and 9. So let's yeah, there's no way you can get 4 and 9 with that answer. So all right. So we're all on the same page. Yeah, so 4 and 9, that was definitely to a different patient's weight. So this is different. So just so we're I'm gonna go over this one as well, just because this is the one. So is this the same 14 that you that we're questioning here?
it's the one you did earlier, but it must
Yeah.
be different on the one with the key because
Yeah.
I got it right with the one that you did earlier. I practiced it again and I got the answer that you got.
Okay, perfect. Yeah. So yes, so the key for the previous one, so that question 14, they used a 110-pound patient instead of 198 pounds. So that's a lot of times the only thing that really changes with these types of questions, these heparin questions, are the patient's weight. Um, and so I'm going to show you a couple of, or at least a kind of like a little shortcut here in just a second. Um, and we'll work through this together. So what I'm going to do is, just because some of you were already on earlier, and this will just be a new way. What I'm going to do is I'm going to change the patient's weight to 188, and then we'll change what that kilogram value is by, because this will be good to work on as a fresh problem. And I wrote down everything, so we're not gonna run out. So you get 85.45 repeating, so that's 85.5 kilograms. So again, I'm just updating, I'm just changing the patient's weight, and but everything else will stay the same. The available will stay the same, the order will stay the same. So what's happening in this question is you're getting two questions to answer, part A and part B for one question. You will see this on your test, I'm assuming. Like I said, I haven't seen your test to know specifically or directly what you're gonna absolutely get, but I know at Allegheny campus they get a question that they have to answer the bolus and the infusion. So they have to answer both those questions to get the one question right. What that means, though, is that if you miss one or both parts, you've only missed one question. So if you miss both parts, you don't miss two questions. But after today, if you don't already have a good grasp on this, you should be fine once we go through this. So what's happening here is we have a protocol that says we're going to bolus the patient with 80 units per kilogram, and then we're going to start an infusion at 18 units per kilogram per hour. We are given a patient's weight. You probably are going to have to do this conversion, so it probably won't be given to you. But if it is given to you, then use it. It also gives us our IV solution, the 25,000 units in 250 ml, and then it gives us a bolus dose of 1,000 units per milliliter. And then the order just repeats what the protocol set up here. So what you're going to do is you're going to take the patient, 85.5 kilograms, and then you're going to multiply by the order, which is the 80 units per kilogram. So this is your example of like a two-step problem where you are being asked to convert the the weight to a unit measurement. Now, I'm not gonna explicitly like set this equal and give you the unit answer because we're not looking for units, we're looking for milliliters. So I'm just gonna go right to solving for the milliliters. So I have units that I'm trying to get rid of and I'm trying to convert it to milliliters. And then I have a conversion for that, which is the 1,000 units per milliliter. And I know because it tells me bolus and I'm calculating bolus. So that's why I'm using that information. So 1,000 units per ml. So that's my available. So if you were to like set this up and you were doing like desired over or ordered over available, this all works out the same. So I'm going to take that 85.5 times 80, divide by 1,000. You're going to get 6.84, but we're going to round that to 6.8 milliliters. So this is where, and I know that over the years, I like to make these reviews a little bit more kind of like watching the review, kind of participating as we're going along. So I will just kind of haphazardly change the numbers, um, and then unfortunately I leave you in lingo or leave you without knowing what the key is, and I apologize for that, but some of that is just because we're doing it like live and I'm always just anticipating that that's where that is, so that's partly why there's no uh updated key other than whatever's currently posted in the OneDrive folder. So that would be your answer, 6.8 milliliters. The shorthand for solving for these, as long as it's following this, what's called the standard weight-based heparin protocol, you're just going to take the patient's weight in kilograms times 80 and divide by 1,000. And that should give you the bolus in milliliters. Whoops. In milliliters. don't don't memorize this like as like a truism. This is just something that's here based off of these units in here. Like in some of the other problems, this won't work because they use a different bolus or they use a different available strength. So just keep that in mind. For calculating the infusion rate, I'm going to take my 85.5 kilograms times my whoops, sorry. I got lost in what I was doing. Times my infusion rate, which is 18. And then I need to convert my units per hour to milliliters per hour. So this is where you've already kind of done this, um, where you've already done the units per hour to milliliters per hour in the previous other types of problems. Here we're going to use the IV available. So 250 ml and 25,000 units. And then we're just going to plug it into our calculator. 85.5 times 18 times 250 divided by 25,000. And I'm going to get, it's 15.39, but we're going to round that to 15.4 ml per hour. So I know I'm giving you a completely different answer now, Karen, than what was even the original one. But I think you said you had already worked through it and you already had it right. The thing that's probably different is I used a different weight. So just pay attention to the whatever weight. And obviously I just changed it again. So for the 188-pound patient, um, it would be 6.8 milliliter for the bolus and 15.4 milliliter per hour for the infusion.
Thank you.
You're welcome. Are there anybody else have any questions on how I got to those answers, or you feeling okay?
Good. I just gonna have to practice.
100%. Yeah, that because this is new. I know it's not like you guys are like doing this throughout your regular like semester. Like, okay, we're going to talk about heparin. This is the probably the first time you're seeing it. So, at least it's early in the week, and you have the whole week to kind of work on this. So, all right. So these are some of the other problems that are following the same lines, but like you could see here, like for this one, um, this is a different, this is a different available, right? So instead of 250 ml, now it's 500 ml. So I have a 100 kilogram patient infusing at 18 units per kilogram per hour. And then I don't want units, I want milliliters. So 25,000 and then 500. And then we should get 100 divided by 25,000. And you should get for this one, it should just be a nice even 36 milliliters per hour. Is that the answer that you actually got, Karen? I know there's two Karens, so guess I should say Karen B.
Not for the other tests. It was this is what, number 15?
Yeah.
I got 16.4 for that one. So it might have been a different question, but I'm
Okay.
yeah.
I have a feeling that they're just different questions. And so this one, this particular review refers to the 25 spring Boyce 230 review. Um, and then there's a key to that as well. Um, and then so those two kind of go together. I would say just focus on those two. I might go in and rename the ones to kind of ignore. So Karen C, you unmuted. Did you have a question or
Oh, no. Well, actually I do. Where can I
okay.
find this? I've been trying to navigate um through SharePoint, but I can't find it.
Um, so you were able to get onto the shared OneDrive?
Yes.
Okay. So click on there should be a folder called Boyce,
Okay.
and then once you click on there, there should be a folder that says 230,
Hmm.
and then you'll see my review materials in there.
Thank you.
You're welcome. Yeah, let me know if you don't find it, because that way at least you can see. And
Wait,
it's
I'm confused on how you did get this answer actually.
okay.
Because I just multiplied everything across the top and then divided it by 25,000 and I didn't get 36 milliliters an hour.
All right, hold on. Let me just see. I may have made a mistake. All right, so 100 times 18 times 500 divided by 25. 1, 2, 3. Yeah, I'm getting 36. What numbers did you
I'm
use?
like totally off. I got 16.38. What did I do here?
Okay, so we are getting the same. So, well, what numbers?
Oh, wait, I've added their weight in there. You didn't put their, oh, you did it. Oh, I'm so stupid. Never mind. I didn't realize their weight was in kilograms already. I was converting 100 kilograms into more kilograms, so that's why.
Oh, okay, so you did
Sorry.
100 divided by 2.2.
Yeah, I
Okay,
converted it. I didn't realize it was in kilograms. I wasn't paying attention.
I
Sorry.
am glad that you saw that,
Yeah.
because that'll save you some heartache, like on the real test, like because it reminds you, pay attention to your units, because in the sciences your units matter. So good. Okay, mystery solved. So that might actually help out with maybe some of these other ones too, because if you like, because even for this one, it's still based off of a 100 kg patient.
Yeah, maybe that's what I did on some of them. I just
You
wasn't, yeah,
just
I need to read it better.
That's okay. No, that's fine. I'm glad that, like we said. Now, I will tell you, I don't think you're going to get questions like this. I think your question is going to be like this one. I think you might get one or two, I think it'll just be one question that looks like this. These other ones are just additional heparin infusion type questions. I don't know that you're going to get these, but it's good to see them just in case you do.
It says there's four heparin. Well, oh,
Well,
it says four heparin bolus and heparin infusion calculations, and there's four of them, so I don't know.
so yeah, so like the that can also just mean like um converting units per hour to milliliters per hour, which is probably where you're going to get three of those and one of the heparin protocol is my assumption. But these are great practice, because if you have to kind of figure out like what to do, and so um that's why these are here to kind of quiz you or test you a little bit. So like let's look at the next one, since this was where there was some discrepancy and it might be based off of the weight. So for this one, it tells you that we need to increase by 2 units per kilogram per hour. So, and thankfully it tells us what they're currently receiving, which is 18. So what do you think I should do with those two numbers?
Add 2 to 18.
Good. Thank you. Okay. Yeah. So basically you're going to set this up exactly the same. Everything's the same as it is up here, but instead of multiplying by 18 units per kilogram per hour, it's 20 units per kilogram per hour.
So would that make it 40?
It might. I have to look. You're ahead of me. So yeah, so 100 times 20 times 250 divided by 25,000, and yes, and 20 ml per hour. Wait, you said 40. What did I do wrong here? Oh, I did 250. That's why. Okay. Yes, 40. 40 ml per hour. Good job. I do. So for Allegheny campus, it's always 250 ml per 25,000 units. So my default is just to automatically like put that as 250 ml. And so I have it memorized like a particular, and so that's the danger, right, of memorizing some of these things. But in my excuse, I've been doing this for over 15 years, and so they do start to run together. I think this is what you'll see is questions like this that are like just your typical heparin infusion questions. Where, but here, like this is really just like doing order over available, right? Your order is the 25,000 units. I'm just going to write you. Your available is 10,000 units. So you've done this before times your 1 ml. And so you would just do, what is this, 2.5 ml? So again, and that could be an instance where it's just a different number. Yeah. 18, I think, is a similar question. This is just asking you to go from milliliters per hour to units per hour. And then we have the following IV available to us. So this is what I showed earlier today for both 130 and 230 students. Oh, I'm sorry, just for 230 students. The way I look at this problem is all I'm doing is going from one flow rate to another flow rate. I'm just making a conversion. So it's like going from ml per hour to drops per minute, or it's like going from miles per hour to kilometers per hour. I'm just changing the units and then kind of being and then doing that conversion. I don't know that you would ever need to worry about doing this in like a real situation, but this is what they're asking you to do. So I always start with whatever flow rate they give me. So they give me 50 milliliters per hour, and then I just want to convert it to units per hour. And so I do so by saying, what do I want to get rid of? Milliliters. What do I want to exchange it for? Units. And then do I have an available that allows me to relate units to milliliters? And I do. This is my IV. They're in the bag together. So the 20,000 units goes up here. 500 mil goes down here. And then I just solve. So 50 times 20,000 divided by 500. And I get 2,000 units per hour. Which makes sense because if it's 25,000 units, or I mean, sorry, 20,000 units and 500 milliliters, that's really not a whole lot because it's the same thing as 50 milliliters per hour, which is actually kind of slow. I'm going to skip a couple of these because I want to get to the nitroglycerin questions. So I'm just going to go ahead and drop down to those. I was trying to see if I had an extra 22 here. And I'll come back. So this is another example that in this instance, we're converting units per hour, the 2,500 units per hour to ml per hour. So we're just doing a flow rate conversion. So I will do this one just to make sure we're all on the same page. So we don't need to worry about what type of saline it is. We just need to know the mLs of the saline and then the units of the heparin. And this is in my IV. This is in one bag. Okay. So this is just my preferred strategy. If you prefer to do something else, that's fine. I always start with whatever flow rate they give me, the 2,500 units, and then I convert the units per hour to ml per hour. And I can do that because of my IV. And I just put whatever's in the IV with the units, whatever's in the IV with the mLs, and then I plug it into my calculator. There's a lot of 25 numbers here. So 2,500 times 250 divided by 25,000. And then, surprise, surprise, I get an answer of 25 ml per hour. So a lot of this is just practicing, making sure you're getting that information together. So if you do happen to reach out to me and email me specific questions because we might be talking about two different tests. And I will give you feedback if you if you're not getting an answer to something, I will give you the feedback you need if you're not getting it from today. All right. That was 23. So like I said, I want to go to um these titration questions just so we are on the same page with them. And then I think 27 is, yeah, 27 is just a range with the titration. So the challenge with the nitroglycerin drip is you're just gonna have to do some converting where we have a different rate, right? So in this instance, we don't have volume over time. We actually have a mass over time or a weight over time. So we have the micrograms per minute. Okay. So you can still calculate something based off of that, but what they're wanting you to do is convert micrograms per minute to milliliters per hour. So I know like it ends up being like, what the heck are we doing here? Why is there all this like craziness that we have to do here? So, but let's just kind of work through this. So it tells us we have a nitroglycerin drip at 50 micrograms per minute. It says that you notice that you have available 25 milligrams in a 250 ml bottle, but then it tells you that your actual available is 100 micrograms per milliliter. So that's perfect. Like don't worry about the 25 milligrams 250 ml bottle because it's already been calculated for you. So it's 100 micrograms per milliliter. So that's what we're going to use. So basically, what we're trying to do is we're trying to go from micrograms per minute to ml per hour. So if you're ever wondering like what I'm thinking in my head, like before, like when I'm setting up these problems, I start off with like saying, okay, here's where I'm starting and here's where I need to go. And then the question is, do I have a way to go from micrograms to milliliters? Like, do I have a way to do that? And that's what the available allows us to do. Okay. Now, what becomes challenging is you might try and do like a ratio proportion, or you might try and like solve this in like a way outside of dimensional analysis. It works. It becomes a little bit more difficult to kind of explain, which is why I always go with the dimensional analysis approach, just because it's for me the easiest way to kind of set up the problem. But if you have a different way of doing it, that's perfectly fine. As long as you're getting the same answer, the correct answer, obviously. So what I'm going to do is I'm going to start off with my 50 micrograms per minute. And then I'm first going to convert minutes to hours just to go ahead and get that out of the way. And then I'm going to do one more conversion where I get rid of micrograms for milliliters. And that's based off of what it says up here. So there's 100 micrograms in every milliliter. And I always say, you might say the horror, but the beauty of setting this up using dimensional analysis is before I do any math, I cross out the units that get crossed out and I make sure I'm in the units I want to be in before I hit to solve. And then I think ends up being 30 mil per hour, but let me just double check. So 50 times 60 divided by 100 is 30 milliliters per hour. So um go ahead and for all of you that are here now, just go ahead and try this number 26. Let me know what you get as your infusion rate. So go ahead and try it and see if you get to the same answer I get. Now, I will add that this is in micrograms and your available is in milligrams, so make sure you account for that. And if you're stuck and you don't know, that's okay to say that too.
Do you want us to answer?
Yeah, you can type it into the chat, or if you want to unmute and say your answer, that's fine too.
I'm completely lost. Can we look through it together, please?
Yeah, absolutely.
Thank you. I
Not a problem.
understand, right? The first step we would want to do is get the milligrams to micrograms.
Hmm.
Okay, so that's times 1,000.
Oh, you're taking the available 50 milligrams and then
Mm-hmm.
converting it to micrograms. Okay. Yep. You can do that. So you get 50,000
Mm-hmm.
micrograms per 250 ml. What would you do next?
Um, yeah, that's where I get lost. I understand then, like, I'm trying to set it up like the dimensional analysis. So then technically, right, we need to figure out the time. I think the time is what's messing me up because it's 60 micrograms per 1 minute, but I guess so what we would need 60 on the top to cross cancel. Hmm. See.
So as a kind of like a starting point,
Mm-hmm.
that again, you don't have to do it the way I did it, but I just start with this is my original rate, micrograms per minute, which is the same thing that they have down here. And then I'm trying
Mm-hmm.
to convert to milliliters per hour. And then the question
Mm-hmm.
is, do I have a way to get from micrograms to milliliters, or do I have a way to get from um, and that's what you did. So all this is good. So everything you've done so far, you have all the things you need. All you have to do is organize it. So, like, my recommendation would be to start with the 60 micrograms per minute and then just kind of put everything else together. But go ahead and take a minute, look at it, and or even just tell me and I'll write it out and you tell me what you want me to do next. Believe it or not, this is very helpful because it helps us to kind of see like where things are like where you might be getting stuck. Because if you're getting stuck, other people are getting stuck.
You said you would start with the order first.
I would, yeah.
Oh, because then we know how much of that we need per hour.
Hmm.
Okay, I see what you mean now. Okay, give me a second. I think I might understand better.
So with the with the 50,000 be on top of the 25 ml, 250 ml.
Well, it depends on how you're setting up your problem. So remember that's your available. So that's just telling you that there's 50,000 micrograms and 250 mLs of the nitroglycerin. So you need to arrange the question such that you're going to get to your answer. So like I'm trying not to answer your question by by what I'm saying there. So arrange it and see what you get. When I wrote the 50,000 micrograms per 250 ml, I just copied exactly as it's written in the available. But technically, you can put either one on the top or the bottom. It just depends on what you're trying to solve for. And the other clue I'll give you is what are we looking for? What number should be on top? Or what unit should be on top?
Oh, I got it.
Okay. Did you get 18?
Yeah, I don't know why I made that so much harder than it needed to be.
It's because like you're looking at it and it just looks like a jumble of numbers and you didn't get into nursing to do math. So that's why. That's it. To me, it's clear as day. I'm sitting there going like, yeah, I would feel the exact same way. You want to care for people, you want to do some work with people, and like, and then of course, then you find out there's a whole lot of charting and a whole bunch of other stuff you have to do. But um, like you didn't sign up for this for math, and so like your mind's not even on that target yet. So, and then once you get there and once you do all this stuff and you prep for next week, then you're just going to forget it, and then you reconnect with me next semester.
So that's basically going to be what it is then. The nitro will be set up that way. It'll either we'll have to convert like if they're not in the same unit, then we'll have to convert one of them. And if they are in the same unit, then it's just one less step to do.
You got it. Yep.
What's the answer?
18 milliliters per hour. Yeah, so the main thing with these questions is like, first of all, I don't know that you're going to do this in a real world situation. Secondly, they're just trying to challenge you to can you solve these more complex questions where they're asking you to do multiple conversions. This is where if you're good or at least are decent with dimensional analysis, no problems or very few problems. And if you have only been doing ordered over available the entire time, and when you get to this and then that doesn't work, then you struggle a little bit. But let me just, so I can write it out just in case we're all on the same page. So I'm going to show you how I would set this up. You can do it any way you want. So I'm going to stick with what Karen had said about like converting this to 50,000 micrograms and just that way everything's on the same page. So what I'm going to do is I'm going to start off with my initial rate, the micrograms per minute. I'm going to convert that to the minutes to hours. So that's the first thing I'm going to do. You could do this last if you want to. It doesn't matter. Just make sure you do it. Then I'm going to convert micrograms to milliliters. And then this is where, so you asked this question, where do I put the 50,000? You want milliliters on top, so you want the 50,000 on the bottom because you can't separate those two things. They can be on the top or the bottom depending on what you're doing, but just make sure they're consistent. So before you do any math, you know already that you're in the right configuration. So you just use 60 times 60 times 250 divided by 50,000, and then you should get 18 milliliters per hour. Now, after I've worked that out, if you did this completely differently and got the same answer, you're doing it right. I am not the end all be all on solving math dosage calc stuff. But I try to be helpful in giving you a strategy with how to solve it if you just don't know what to do. If that makes sense. Um, I'm gonna pull up number 27 just because I don't think you're gonna have a question like this, but um those those of you going into because I think you're all starting at 230. Um,
Mhm.
you're gonna have pediatric dosage, and you're gonna talk about ranges, like a safe dosage range. And this is a great example of kind of like how to calculate a range. But I don't think you're gonna have a question like this on your test, but I'm gonna show it to you anyways because basically it's just like doing two questions like we just did previously. So I'll work through this with you guys. Um, so this just tells us that we're going to be lowering someone's blood pressure using nitro. That's going to be titrated. And then you see this, it says 15 to 200 micrograms per minute. So there's a range there. Now you might be going like, oh man, I'm gonna have to do 15, 16, 17. No, you just need to know the low end of the range and the high end of the range, and then just work with those numbers. Okay. So this is just telling you that there's a range, and we just need to know what the bottom of the range is and what the top of the range is, or the high and the low. So we make the solution by adding 50 milligrams um, to the nitro solution, and then the final solution will actually contain 250 milliliters. So once everything's said and done, these are the two pieces of information that help us understand like what it's supposed to be. I just need to calculate what the rate's going to be in milliliters per hour. So how do I do that? So the first thing I'm going to do is I'm just going to set up the bottom range and the top range. I'm going to do exactly what I've been doing this entire time. I'm going to take the 15 micrograms per minute, and I'm going to take the 200 micrograms per minute. So basically, I'm setting up two problems, and then everything I care about exists within the range here. But I need to know the low end, and I need to know the high end of the range. So I'm going to do exactly what I've been doing in the previous questions. I'm going to convert, I'm sorry about my line here. I'm going to convert minutes to hours. I'm going to convert minutes to hours. And then I'm going to convert micrograms to milliliters because that's all this is. It's the same type of question that was in the previous two questions we just went over. The milliliters is 250. The micrograms, remember it's in milligrams here, so we're going to convert that to micrograms. That's 50,000. That's the only thing I'm kind of changing here without telling you how I did that. And then again, before I solve anything, I just make sure, did I get rid of micrograms? Yes. Did I get rid of minutes? Yes. What am I left with? ML and hour. Same thing here. And so now we can calculate our range. So we have 15 times 60 times 250 divided by 50,000. And I get, and hopefully you got as well, 4.5 milliliters per hour.
Mhm.
And then for the top of the range, 200 times 60 times 250 divided by 20, or shoot, 50,000. And I get 60 ml per hour. So like I said, I don't anticipate that you'll have a question that looks remotely like that, but I think it's a good one going into 230, especially when you do the pediatric safe dose ranges, because you need to know how to calculate the range. And then basically what they're going to ask you is they're going to tell you the order is, let's say it's 25 milliliters per hour for a particular protocol. And then they're going to give you this, and you're going to have to calculate the range, and you just have to make sure it's safe. And you could see that if it was 25 milliliters per hour, it falls within the safe range for this particular thing. Now, I don't know that you're doing a blood pressure lowering procedure on a pediatric patient. I mean, you could be if they're, an older pediatric patient, but and obviously there's different comorbidities that I'm unaware of, but I think you get the point of what we're trying to do here. So,
Don't you have to convert the units though, because they're not the same? Like I'm confused. Like the 15 micrograms isn't the same as, like you have to get the units into the same thing, right? Because I didn't get those answers.
well, did you convert milligrams to micrograms?
No, I converted micrograms to milligrams.
Okay. Well, then you should have gotten like, and then you left this as 50 milligrams.
Um, yeah.
Okay. So
Okay, yeah, I think I just read it wrong. I don't know what I did.
that's okay.
Go over it again.
So you had 0.015
Yeah.
milligrams
Uh-huh.
times 60
Uh-huh.
times 250
Mhm.
divided by 50.
Uh, yeah, that's what I put 50,000. I think I was like following your
Oh, okay.
that's perfect.
No, and
I need to
some,
figure it out on my own here. 50, okay.
yeah,
Yeah, because I don't need to do that. That's right. You converted it the other way. Yeah,
right.
that's why I was getting confused. Okay.
Yeah. So just whichever way you choose
Hmm.
is fine. Like
Okay.
me personally, I hate that. Like I look at this and I go, ugh, it looks too small. But I'm okay with this big giant number. You know what I mean? So for me, it's just a preference. But what you did was fine. You converted that to milligrams, um, the 0.015. Just don't also convert that. And that was probably just because I had done that and I
Yeah, it's
was
because you're doing it the
confusing.
other way, and I'm like trying to follow you, but then do it. Yeah. Okay. I'm good.
Okay, good. Yeah, let me know if you don't get the 4.5 and the 60 based off of how you did it. It should work out exactly the same.
Yeah, I'm good. I got it.
Okay. All right. So we're kind of getting to the end of the hour. Is there any of these that we can work through together just to confirm? I think we went over enough and kind of got through. I know I didn't definitively go through all of these one by one, but that's just because usually um, you're able to get those answers. But if you do run into where you just aren't 100% sure, or you're looking at an old test and the key doesn't match up, just message me which question it is, like copy paste or send a screenshot, and then I'll get you an answer. So I'll create the key for you. I just most of the time, as long as you're starting to set these things up, you're probably fine as far as that's concerned. But I know you just want to double check your answers, and I'd be doing the same thing. So
Will we be able to go back and watch this?
say that again.
Will we be able to go back and watch this?
Yeah. So in the where you got the link for this, the Zoom link. Underneath it, it says resources. So there's the link for the shared OneDrive folder where I upload the practice things that I've kind of created or collected over the years, and then I will upload it to my YouTube channel, and then there should be a link for that as well. So if you don't have those links, just email me, and then I'll have this uploaded onto YouTube. If not tonight, tomorrow. All right. If there's no other questions, like I said, feel free to email me if you do have any questions between now and then your test next week. Um, if and if we need to get together and do another Zoom, I'm happy to do so. I should have some time like tomorrow and Thursday and potentially Friday. But and if not, then I'll wish you the best of luck. I think you're gonna do just fine. You're worrying the right way. At least you're not going into this not knowing anything about math. It's just a matter of just trying to sort this stuff out. And like I said, I think some of these questions are harder than what you're gonna see on your actual test. So if you can get through these while you're practicing them, I think you're gonna be very well prepared.
Okay, thank you.
You're welcome.
Thank
Yeah, good.
you.
You're welcome. Good luck on your tests, everyone.